Hello, this is Mr. Stansbury. I'm going to take you through the 2016 Math Studies Paper 1. Okay, there will most likely be some errors in here. Hopefully I'll keep most of those to a minimum, and we'll try to catch them as we go. All right, number 1. This here, probability that Nikita wins a tennis match depends on the surface of the tennis court on which she's playing. Probability that she plays on a grass court is 0.4. That's this here. And probability that Nikita wins on grass is 0.35. Probability that she wins when she's not on grass is 0.25. Complete the following tree diagrams. So we need to know that the branches of these tree diagrams should always add up to 100. So 0.4 and 0.6 adds up to 100. 0.35 and 0.65 adds up to 100. 0.25 and 0.75 adds up to 100. This here is worth 3 points. So each one of those there is going to be worth 3 points. Okay. Part B is also 3 points. Find the probability that Nikita wins a match. So that's going to be this here and this here, right? So to figure out this probability here, we're going to go 0.4 times 0.35, and we'll calculate that out. And to find this one here, that's 0.6 times 0.25, and we'll calculate that one as well. All right, so we do 0.4 times 0.35, that gives us 0.14. And then for the other one, we've got 0.6 times 0.25, and that gives us 0.15. Okay, so either one of those should work. So it will work if she wins on grass or if she wins on not grass. So since it's or, that means we're going to add these two together. So we're going to do 0.14 plus 0.15 to get 0.19 is going to be the probability that Nikita wins. Okay, so let's check our answers with the mark scheme and see what they've got. Okay, so there's our 0.6. Oops, better not try to write on that. There's our 0.6, our 0.65, and our 0.75. There's 3 points there. Okay, award A1 for each correct entry, so that's 3 points there. And then for the second part, we want to do 0.4 times 0.35 plus 0.6 times 0.25. Okay, and that's what we did. That was our 0.14 and our 0.15, right? So it says award a point for 2 correct products from their tree diagram seen. So there's our 2 correct products. Award M1 for the addition of those. That's where we took our 0.14 times plus our 0.15, and then we get our last point for getting the 0.29 on there. Okay, and this follow through part here is basically if you messed up one of these numbers here, but you use those wrong numbers correctly in these formulas here, you would still get full points down here. You would just lose a point up here. So like if this was 0.55 instead of 0.65, we would, if we use that correct number, that incorrect number correctly down here, we would still get our 3 points down here. So we'd end up getting 5 out of 6. All right. Okay. Let's move on to problem number 2. Timmy's sailing boat has a sail in the shape of a right-angled triangle, ABC. BC is 5.45 meters. Angle CAB is 76 meters, and angle ABC is 90 degrees. So they've labeled all that for us. Calculate AC, the height of Timmy's sail. So this here is our AC. Normally we would put X there to find our, that's what we normally put if we're looking for a missing side, just to make sure that we end up getting full credit on all these. Let's write this as AC because it says to calculate AC. So let's put our variable as AC, which is this side A to C. Okay, so in looking at this here, this side, look, we've got a right triangle, so we can use our good friend SOHCAHTOA, right? SOHCAHTOA. Okay, so let's do from this angle, this is the opposite side, and this is the hypotenuse. Okay, so opposite and hypotenuse tells us that we want to use sine. So we're going to do sine of 76 is going to equal opposite, which is 5.45 over the hypotenuse, which is our x, which again we should put as AC. Okay, so we want to get AC all by itself. So let's do this. Let's multiply both sides by AC, because that at least gets it out of the denominator. So now we have AC sine 76 equals 5.45. So we want to get rid of the sine 76. So we're going to divide that by sine 76. Let's go back. That's a little messy. So we've got AC sine 76 equals 5.45. So we're going to divide by sine 76, both sides. Right? So we're going to get that AC, is 5.45 divided by sine 76. Okay? So, first thing you want to do on here is make sure, first time you do any kind of trig function at all, make sure you go into your mode and make sure that you're in not radians, but degrees, right? Which we already are, so we're good to go. So now we can do 5.45 divided by sine 76 will give us side AC. 5.45 divided by sine 76. And we get 5.6168. Right? And if you'll remember in the directions on the front page, which actually doesn't show on here, but it will tell you that if it doesn't, unless it specifies something different, always go to 3 significant figures. So here's our first, second, third. We want to round to that number here. So AC is going to be 5.6. That 6 tells the 1 to get bigger, so 6.2. And always, always, always put your labels on there. So it's 5.62 meters is AC. Okay? Okay, let's see what else they got for us. Okay. William also has a sailing boat with a sail in the shape of a right-angled triangle, TRS. So that's this one here. RS is 2.80. And the area of William's sail is 10.7 meters squared. So this area here is 10.7 square meters. Okay, it says calculate RT, the height of William's sail. So we're going to try to find this here, RT. Okay, so what we want to do here is we just want to use the plain old area formula of a triangle, and that is actually on your formulas page. So let's look that up here, and that's the prior learning, and it's area of a triangle. Area equals 1/2 base times height. So let's use that formula there. We got area equals 1/2 base times height. So we know the area is 10.7 square meters, right? And then we know that that's going to be half the base, which we know is 2.80. 2.80 times our height, which is RT, right? And again, remember RT is just one variable. It's not R times T. Okay. Now we want to solve this thing so we get RT all by itself. So we got 10.7 meters squared. Half of 2.8 is going to be 1.40 RT. Now we just want to divide by 1.40, and that's what, meters, right? Meters. So that's gone, and we take that and divide that by 1.4 meters as well. So let's see what we get for that. Okay, so we got 10.7 divided by 1.4. And we get 7.6428, so let's round that to the third significant figure, 7.64 equals RT. And that's 7.64 meters, right? Because it's a length. Always put your labels on there. Okay, so that's B. And then the last part says calculate the size of angle RST. So RS to T, that means that's going to be this angle right here, R to S to T. Okay, so from that angle here, we just figured out that this RT side is 7.64 meters, right? So this side here is the opposite of that angle, and this side here that we have is the adjacent, right? So if we've got opposite and adjacent, that is from SOHCAHTOA up here, that's the tangent, right? So tangent of the angle is opposite, which is 7.64 meters, over adjacent, which is 2.80 meters. Okay. Remember, when you're doing this here, whenever you're looking for an angle, it's always the inverse tangent, right? So we want to do second tangent, and that's tangent to the negative first. And then we're just going to want to put in 7.64 divided by 2.80, or just 2.8, right? Push equals, and we get 69.87. There's our third significant digit. This 7 tells the 8 to get bigger, so it's 69.9 degrees is what angle RST is. So RST, I'm even going to do this, angle RST is 69.9 to 3 significant figures. Okay, let's check that with our rubric and see if we're doing all right. So part 2, units are required in parts A and B. Okay, so we get 1 point for setting up sine 76 as 5.45 over AC, which we did. Okay, you get a point for correct substitution, and then you get your second point for getting the correct answer. 5.62 meters is what we rounded ours to, so we got our 2 points there. The units are required. So if for some reason you put just AC as 5.62, you didn't put the meters on there, you're only going to get the setup point. You're not going to get the answer point. And notice it's in bold, so they're going to hold true to that. Okay. Part B, we get a point for correct substitution in the area of a triangle formula, which we did, or equivalent. So if you've got another area formula that's going to work for that, don't know what that is, that would work also. Okay, maybe it would be base times height divided by 2. That would work too. Okay, so we did 1/2 2.8 times RT equals 10.7, right? And then we solved that and got that RT was 7.64 meters. Okay, and again, it says here units are required for the second point. So you get 1 point for substituting into the correct formula, 1 point for getting the right answer with the units. Okay. Last part here. Let's see. The angle, tangent of RST is the 7.64 over 2.80, which is what we had. You get 1 point for correct substitution into the right trig formula, so you'd have to have the tangent, and then you'd have to have your answer from part B, even if you got it wrong. If you substituted in correctly, you'd still get your point, divided by 2.8. Okay, and then we ended up with 69.9, which is what we got. Now, there's an important note down here. It says follow through from B. The answer RST is 69.8 is if you took, let's see, this number, the 7.64, and divided by 2.80, and you rounded it to 8.14 is premature rounding, and you would only get 1 point for that. You would not get your 2 points. So when you figure this part out here, the inverse tangent, just do second tangent of 7.64 divided by 2.80, and then push equals. Don't try to simplify this first and put this rounded number in there. Okay? Okay. Off to number 3. Okay. Let's see. We got to go back up so we can see the whole thing again. Okay. In a school, 160 students take a math test. Their scores given as marks out of 90 are summarized in the cumulative frequency diagram. Okay, so write down the median score. So the median is the score that's right in the middle, right? So you either got to take the middle of 160 or 90. 90 is the total number of marks, so that's not what we want the median, and we want the median of the 160 scores on the test, right? So we would want to take 160 divided by 2, and that gives us 80. So we're going to want to find the 80th score. Okay, that's not this 80, but this one here. And notice that's right in between the 0 and the 160, right? So what you want to try to do is find this point here and draw a straight line over there to right to where it intersects there. And then you draw a straight line from there down to here. And then you try to estimate what that number is right there. That looks like that's pretty close to 48. Okay, so write down the median score. It's going to be 48. And note that when they say write down, they're not going to look for any calculations anywhere. All you got to do is just write it down. So 48 is our median score. Okay. Next info it gives us is that the lower quartile of these scores is 40, which should hopefully make sense, because if the median was 80, to find the lower quartile, you take half of the 80, right, which is 40. So that would hopefully make sense. So then you'd go over here to 40 and then draw a straight line. Oops, that didn't work. Let's see, do 40, and you draw a nice straight line over to where that hits, right? Oops, close enough right there. And then you draw, oh man, I'm having a hard time. And then you draw a nice straight line down from that there, which looks like it hits right there at 40. Okay. Oh, because it says find the interquartile range. Sorry, it says I kind of got a little ahead of myself before I was reading the directions. But so find the interquartile range, which is going to be quartile 1, right? Which we know is quartile 1 is 40, and we also want to find what quartile 3 is. So if the median is 80 and then half of that is 40, we'd want to go 80 plus another 40, which is 120, and find that number there. Right? So we take that, draw ourselves a nice straight-ish line over there, and then we draw a straight line down from that, which looks like, oops, I'm off a little bit there, but that looks like that's pretty close to 58 we're going to go with. Okay, so the interquartile range, remember you got to subtract those two. So you subtract quartile 1 from quartile 3. So we do 58 minus 40. Gives us 18 is our interquartile range. Okay. Last part says the lowest score was 6 marks and the highest score was 90 marks. Draw a box and whisker diagram on the grid below to represent the student's exam scores. Okay, so 6 here is about, let's go with about there. That looks like 6. Okay, and then the highest was 90. So I'm going to put in 1 there, and that's 90. We need our lower quartile, which is right here at 40. We need the upper quartile, which is at 58. Okay, right? That's always a good idea to just write down what numbers those actually are. So that's 40 and that's 58. And then our median we found was 48, so we'd want to draw one right there at 48. And then remember, we make our box around those there. And then we want to connect our whiskers in here. So I'm going to do this. Oh, let's try that again. So draw ourselves a nice straight line there, and then a nice straight line from there. Man, why do I have a hard time? A nice straight line back to there. Okay, so there's our box and whiskers. Okay, so let's double check against our mark scheme to see how we did on that. Okay, so move into number 3. So we wrote down our median score, which was 48. There we go. Our interquartile range, 58 minus 40. So you get 1 point for showing the 58 and the 40, the upper quartile and the lower quartile. And then you get another point for subtracting the 58, the 40 from the 58 to get 18. Okay, so there's 1, 2, 3 points. And then for part C, if you'll notice on their box and whisker, they drew a straight line here instead of a dot like we are used to seeing. So I don't know if you happen to remember to draw a straight line, since they have it on their mark scheme, that would, should give you a better chance of getting full points. I would imagine that if you put a dot there that you'd still be okay, but you can never be too sure. Okay, so then we've got our lower quartile was at 40, our upper quartile was at 58, our median was at 48, upper was 90, lower was at 6. Okay, so we got all the same numbers that they did. So it is important to look at this note down here. It says award A1 for the correct maximum and minimum. So there's our 6 and our 90. We had that. A1 for their correct median. That was this one right here. We had that. And A1 for 40 right here, and their upper quartile, which was 58. Okay. Now it says award a maximum of 2 out of the 3 points, A1, A1, A0. That means you didn't score that last point if the horizontal line goes through the box. So if you drew this line and it went all the way through the box, that's minus a point. Or, here's the interesting part, or if a ruler has clearly not been used. So they want all these lines to be nice and perfectly straight. So you'd want to use a ruler to draw all these lines instead of just free-handing it. Because if you freehand it, you're going to only get, even if you do everything right on the whole problem, you're only going to get 5 out of 6. That's just kind of the way they grade their tests. A little strange, but we'll go with it. Okay? All right. Let's move on to number 4. Fresh Wave brand tuna is sold in cans that are in the shape of a cuboid, which is a rectangular prism here, right? With length 8 centimeters, width 5 centimeters, and height 3.5 centimeters. So let's write those on there since they didn't already. So we got 8 centimeters, 5 centimeters, with 5 centimeters is the width, and then 3.5 centimeters is the height. Okay, Happy Fin brand tuna is sold in cans that are cylindrical with a diameter of 7. So from here across to here is 7. Pretty sure they're going to have us find volume at some point. So instead of writing the diameter, I'm going to write the radius, which is 7 divided by 2, 3.5. This is centimeters, right? And then the height, excuse me, the height is 4 centimeters. Okay. So first thing they want us to do is find the volume in cubic centimeters of a can of Fresh Wave tuna. So there's our Fresh Wave tuna can. Okay, so to find the volume of that, hopefully you remember that it's length times width times height. If not, it's on our formula sheet here. And let's see if we can find it. Not prior learning. It's going to be on this here. Volume of a cuboid. Look at that. It even tells us it's a cuboid. Length times width times height. Okay. And then volume of a cylinder is going to come in handy there too. Its volume equals pi r squared times h. That's going to come up on the next problem. The next part. Finding the Happy Fin tuna. Okay. So Fresh Wave tuna is going to be 8 centimeters times 5 centimeters times 3.5 centimeters. Okay, so we put that into our handy-dandy calculator. 8 times 5 times 3.5 gives us 140, and this is cubic centimeters. It already says right here, find the volume in cubic centimeters, so you're not going to necessarily have to have the centimeters cubed on there, but I can't imagine that they would take points off. I would always label your numbers if there are any. Okay. Happy Fin tuna, that was the other formula we looked at, and that is volume is pi times radius squared times the height, right? So in this case here, our volume is pi times our radius, which we figured out ahead of time is 3.5 centimeters squared, times the height, which is 4 centimeters. Okay, so volume is going to equal, let's calculate that out. Whenever you're using pi, always hit the pi button. Don't hit 3.14 because that's going to most likely throw your answer off a little bit and possibly lose you a point. So let's use the pi button. Second pi times 3.5 squared times 4 gives us 153.93. We're rounding this to 3 significant figures, so 153. 3 is our third significant figure. The 9 tells the 3 to get bigger, so it is 154 cubic centimeters for the volume for the Happy Fin tuna. Okay? The price of tuna per cubic centimeter is the same for each brand. Okay? A can of fresh wave tuna costs 90 cents. Calculate the price in cents of Happy Fin tuna. So in other words, it's going to cost the exact same per cubic centimeter. So this Happy Fin's got a little bit more, let's see, what is it? Tuna that's in this. So this one should cost a little bit more. Okay, so there's a couple ways you can go at this. I'm going to look at this as a ratio. So I'm going to say I know that 140 cubic centimeters is going to cost 90 cents. How much is 154 cubic centimeters, cubic centimeters going to cost, right? So we should hopefully be able to look at this as a ratio. So 140 costs 90 cents. 154 is going to cost how many cents? Okay, this can be set up all sorts of different ways. You could put 90 over 140, x over 154. You could even do 140 over 154 is 90 over x, or vice versa. So lots of different ways to do that. Remember, when you get two fractions equaling each other, let's just do cross products is probably the easiest way to do that. So we'll do 90 times 154 should equal x times 140, so 140x, right? So we bust out our calculator, and we've got 90 times 154 gives us 13,860 equals 140x. So we divide both sides by 140, and we get x is going to equal, so divide that answer by 140, and we get x is going to be 99 cents. Okay, so I wouldn't even circle the x equals, it's just going to be just 99 cents. Calculate the price in cents of a can of Happy Fin tuna. So let's look and, let's take a look at our mark scheme here and make sure that we're doing okay on that. See how many points we got. Okay, 8 times 5 times 3.5 is 140. Okay, so you get 1 point for correct substitution into the formula, and then you get another point for getting your 140, right? Because that was a 2-pointer, wasn't it? Let's see. Yeah, these two here were worth 4 points, so it's going to be 2 points for the 140, and another 2 points for the 154. Let's make sure that's what we were supposed to get. Yep, 154. Okay, or 49 pi, they would have taken that too. Okay, and then the second part was just calculating it out. So award M1 for multiplying the given 90 by their part in A11. So 90 times 154. Okay, and then let's see, and then dividing by the 140. So that's exactly what we did, and we got 99. And it says, note, award a maximum of 1 point instead of 2 points if the final answer is not an integer. So we got 99 cents, which is an integer. Now let's just say if it was 99.4, it wouldn't make any sense to put 99.4 cents because you can't pay 0.4 of a cent. So that's why they're saying make sure that your answer is an integer. Obviously, if it was in dollars, let's say it was $1.04, if you put 1.04, that would be fine as long as it was in dollars. But since it's in cents, you can't have any kind of decimal. Okay? All right, moving on to number 5. Consider the following statements. Z, x is an integer. Q, x is a rational number. And R, x is a real number. Okay, so write down in words, not Q. Okay, so Q is x is a rational number, so we would say x is not a rational number. Right? Okay. I would imagine that we could also write x, if it's not rational, that means it would be irrational. So you could probably also write x is an irrational number, but x is not a rational number should work out just fine. So let's just leave that. Okay. Write down a value for x such that the statement not Q is true. So basically we got to find some value for x that's not a rational number. So what is an irrational number that you can think of? Pi is a pretty good irrational number, and so is pretty much any root, like root 2, root 3. Root 4 wouldn't work because root 4 reduces down to just plain old 2. So any any root that you can come up with that doesn't reduce down to a perfect square, that's not a perfect square, should work out. Okay, so either one of those would work. I would probably just list one, like pi would work just fine, or root 2. I probably wouldn't list both of them, but anyway. Moving on, write the following argument in symbolic form. If x is a real number and x is not a rational number, then x is not an integer. Okay, so since we have the if and the then, we know we have this implication here. So we've got our arrow that we want to make sure that we have. So if x is a real number, so x is a real number, that's R. So if x is a real number, and is represented with the up arrow, right, or the caret. X is not a rational number, so here's is a rational number, so not a rational number would be not Q, right, just like we had up here, so not Q. That implies that x is not an integer. So x is an integer is z, so that would mean we would put not z. Okay? And since these things are together, that implies not z, we'd want to put these here in parentheses. Okay? All right, last one. Phoebe states that the argument in part B can be shown to be valid without the need of a truth table. Justify Phoebe's statement. So if we have something that's not an integer, let's back up. So all integers are rational numbers, right? So all integers are rational numbers, right? So integer was our z. So if it's not rational, okay, if it's not rational, then it can't be an integer. Okay, so if it isn't rational, it can't be an integer. Okay. Note that this one is just 1 point here, so this is kind of a, I don't know, that this is a tricky one to try to see if you can go through and explain all of that there. So it is only 1 point, so it's pretty much an all or nothing. You either get it or you don't get it. So let's check really quick with our mark scheme. So first part, X is not a rational number, so that worked. And notice it also says X is an irrational number would be acceptable. Okay. Part 2, all we'd have to do is list any non-rational or irrational number, which is pi or root 2. Those are the ones that we were coming up with. You only have to list one, so probably just list one. Okay. Part B, we have R and not Q in parentheses, just like we had, implies not Z. Okay, so that is exactly what we had right there. So we're good on that one. Okay, so that's going to give us all 3 points, but it is nice because they break this down point to point. So you get 1 point for the implication arrow scene, 1 point for the not Z, okay, and then also 1 point for the R and not Q in parentheses. Okay, it says the parentheses are required. Okay, and remember the first part is the antecedent. That's the antecedent, and then the second part of an if-then is the consequent. Not that they will that you'll be asked that on the test, I would imagine, but just in case. So the last one where we had to explain Phoebe's claim, it says all integers are rational numbers, and therefore x cannot be an integer if it's not a rational number. Okay, or something else equivalent. Or if x is an integer, then x is a rational number. Therefore, if x is not a rational number, then x is not an integer. The contrapositive. That's I don't know if I'd come up with that one. That one's a fairly tricky one. But also, I thought this was interesting. Note, except if x is not in Q, then x is not in Z, with a Venn diagram showing R, Q, and Z all correctly. So you can actually show that with a Venn diagram as well. Okay? All right. Moving on to number 6. Okay. One of the locations in the 2016 Olympic Games is an amphitheater. The number of seats in the first row of the amphitheater is U1 is 240. The number of seats in each subsequent row forms an arithmetic sequence. The number of seats in the 6th row, U6, is 270. So if you remember how we did this in class, we did this. So this is like the n, the number of the number of terms here. So the first term, second term, third term, fourth, fifth, and we need to go up to 6 terms because we got U6 and U1. Right? So if you'll remember, we did this here, and we said, okay, first term is 240, right? And then the last term is 270, right? And then we said, oh, okay, each time we go up by 1, that's going to be a difference, right? So we just go, how many little spots over do we have to add? Each one of these is a difference, right? So we know that if you start with 240, that, and then you add 1, 2, 3, 4, 5 D's, and add 5 differences, that should give us 270. So now we would just need to solve for the D. So subtract 240. And that gives us 5D equals 30. Divide by 5. And we get D equals, the difference would be 6. Okay? And that would be worth 2 points. Okay? There are 20 rows in the amphitheater. So part B asks, find the total number of seats in the amphitheater. So this is going to be, it tells us right here that it's an arithmetic sequence. So we're finding the total number of seats. So this is going to be the sum of an arithmetic sequence. So we want to find that on our formula sheet. Okay, so sum of an arithmetic sequence. Let's see if we can find that. Here we are. The sum of n terms of an arithmetic sequence. So we're going to use either this or that. Notice that we got the sum is this or it equals that. This is not one big equation. A lot of people get confused with that, just like this one down here. It's not one big equation. It's two different equations that you can use. So this one is the one we want to use if we know the first term and the last term. This is the one we want to use if we know the number of terms, first term, and the difference. We do not know the last term, so we want to use that one. Okay, so let's copy that formula down and use it. Okay, so here's our formula here. So the sum is going to equal n is the number of terms in the sequence, right? So there's 20 rows, so that's going to be our n. So we're going to do 20 over 2 times 2 times u sub 1. That's our first term. U sub 1 is 240. So 2 times 240 plus number of terms, which again is 20, minus 1, all times the difference, which we just found over here is 6. Okay, so really we can just take in our calculator and we can just enter that whole thing in there, right? So 20 divided by 2, parentheses, 2 times 240, plus, and then another set of parentheses, 20 minus 1, or you could just put 19 if you figured that out ahead of time, all times 6, close our parentheses, and we get 5,940. Okay. Notice that our third significant digit would be 4. So if this was like 5,941, we'd want to round it to 5,940, right? Let's see, unless it says anything different up here, which I don't see. Okay, so that's our sum. So this is B, right? The sum. The total number of seats in the amphitheater is 5,940, okay? Anisha visits the amphitheater, and she estimates that the amphitheater has 6,500 seats. Calculate the percentage error in Anisha's estimate. So, percentage error, that's something else that is on our formula sheet, and here it is. So let's copy that down and use that. Okay, so here's our formula here. Okay, so it says it's going to be the absolute value of VA, and it even tells you what VA and VE is. VA is the approximate value of V, so there's our approximate value, 6,500, minus VE, which is the exact value, which we figured out over here is 5,940, so minus 5,940, all divided by the the exact value with the VE again, so divided by 5,940, and it's the absolute value of that times 100 is going to be the percentage error, and that's the E. Okay, so E equals. So let's calculate that out and see what we get. So we get 6,500 minus 5,940 gives us 560, and we're going to divide that by 5,940, and that gives us 0.94. We want to take the absolute value of that. It's already positive, so we're good, and we multiply that answer by 100, and we get 9.427. The third significant digit in this is the 2. The 7 tells the 2 to get bigger, so it's going to be 9.43. So we got 9.43, and it says that it's right there, percent, and it even says the percentage error. So it's 9.43% is going to be our percentage error. Okay, let's check that on our mark scheme and see what they've got for us. Okay, this number 6. So here, now if you'll notice on here, they say award M1 for correct substitution into the arithmetic sequence formula. Back here, I did not put it into the arithmetic sequence formula. This over here is really ends up being the arithmetic sequence formula. So there's a good chance that we would get full credit for that, but it's not guaranteed. So it might not be a bad idea to actually use the arithmetic sequence formula. to plug that in. So let's do that. Let's find that on here. Nth term of an arithmetic sequence is this here. So let's copy that down and do that, and we'll see how similar it is. Okay, here's our arithmetic sequence that we just found on that other page there. So u sub n is going to have to be our last term. So that's 270. So we do 270 equals u sub 1, the first term is 240, plus n, number of terms. In this case, we went from 1 to 6. So there's going to be 6 terms minus 1, all times d. And this is the other way to find d, right? So we got 270 equals 240 plus 5 times d. And if you'll notice, look, that's what we have. 240 plus 5d equals 270. So we'll end up getting 6 out of that there, right? By subtracting 240 from both sides, we get 30 equals 5d, divide by 5. And we get that d equals 6. So either way, we'd get d equals 6 on that. Okay? This way, you're guaranteed to get the points. This way, you might get the points. I like this way better because I don't have to worry about figuring out which formula it is and plugging in the right stuff. I'm just using my brain to figure that out. So, but this way, you're guaranteed to get the points. I'm not 100% sure on that one. So, try to go with that one, I guess. Okay, so here's our 2 points, for one for correct substitution and then one for getting the 6. Okay, now for part B, we plugged it in the formula, and that's exactly what we did. N over 2. This is exactly what we plugged in, and we got 300 and let's see. U sub 20 is 354. We did not get that, but we did get this, our 5940. Okay, so you get 1 point for correct substitution into the formula, which we did, and then you get another point down here for getting the correct answer. This is or, so you could have done this, or this, or this, and you could actually add 20 terms in a row to come up with that 5940. But most people that do this, they're going to end up pushing a wrong button at some point or another, and you're going to end up getting the wrong answer there. So you would lose both points on that because you get the wrong answer and you wouldn't have done this correctly. So I'd stick with the formula if you can. You can. Okay. Part C was our percentage error, and that's exactly what we did. Absolute value 6,500 minus 5,940 over 5,940, multiplied it by 100, and we got 9.43%, just like they did. Okay, so that would get us our full points on number 6. Let's now take a look at number 7. The equation of the line L1 is y equals 2.5x plus k. Point A is 3, negative 2, and that lies on this line L1. Find the value of k. Okay, so to find the value of k, we're just going to want to plug in our x, which is 3, and our y, which is negative 2, into this formula, and the only variable we have left is k, so we can figure out what that is. So let's do that down here where we've got room. So we got y is negative 2 equals 2.5 times x, which is 3, plus k. So we get negative 2 equals 2.5 times 3 is 7.5 plus k, and we subtract 7.5 from both sides, and we get that k is negative 9.5. Okay, so that's part A. Next it says the line L2 is perpendicular to line L1, perpendicular to L1, and intersects L1 at point A. Okay, so we got this here. Let's just pretend that that's that line. Okay, this is L1, and now they're saying we've got L2 is running through. This is L2 again. Sorry, it's so crooked and awful, but it runs through this point 3, negative 2, perpendicular, so it makes a right angle right there. Okay, so for part B, it says write down the slope of L2. Okay, so if it's perpendicular to this line, this L1 here, and the slope of the L1 is 2.5, what we want to do is we want to take the inverse reciprocal, flip it over, and switch the sign. So I'm going to take 2.5 and I'm going to turn that into a fraction to make it easier to flip over. So 2.5 is the same thing as 5 halves. So then now the perpendicular to this would equal, you switch the 5 halves over, you take the reciprocal, 2/5, and then you also take the inverse. So it's going to be negative 2/5 is going to be our slope of the perpendicular. Okay, so that's B. Part C, find the equation of L2. So we know the slope of this L2, and we also know that it goes through this line here. So it's really just like what we did up here, except for now instead of a 2.5 slope, we're going to have a negative 2/5 slope. Let's maybe do this. Let's turn that negative 2/5 into a decimal. That's negative 0.4 as a decimal. That might make it a little bit easier. Okay, so find the equation of L2. Give your answer in the form y equals mx plus c. So we could put this into the point slope formula, or since they give us this formula right here, let's just use this one to figure out this here. So c, we've got y equals mx plus c. We know, again, it runs through this same point, this 3, negative 2. So y is going to be negative 2. Our slope is now negative 0.4. Our x is 3. And plus c. Okay, so we get negative 2 equals negative 0.4 times 3 is negative 1.2. Right? And then we got to add the 1.2 to both sides to get c all by itself. Negative 2 plus 1.2 is negative 0.8 is what c is. That is not the formula. That's just figuring out the c. So now we have to plug the m and the c back into the formula. So we'd end up getting that y equals m, which is negative 0.4 x plus our c, which is negative 0.8. So instead of writing plus, let's put minus 0.8. That's our perpendicular formula there. Okay, that's part C. And then there's a part D also. It says write your answer to part C in the form ax plus by plus d equals 0, where a, b, and d are all integers. So what they're saying is we got to move everything to one side, and we can't have any decimals or fractions. So let's do this. Let's start with this and move everything to one side first. So we got y equals negative 0.4x minus 0.8. So we're going to add the 0.4x and the 0.8 to both sides. Right? So that gets rid of these over here. So we end up getting 0 on the right side. And then we have, you want to have x first, y second, and then the constant third. So we got 0.4x plus y plus 0.8. Okay, now these all have to be integers, so we have to get rid of those decimals. So let's see, if we multiply everything by 10, it'll definitely get rid of all those decimals, right? So let's try that. So 10 times 0.4 is 4x, 10 times y is 10y, and 10 times 0.8 is 8 equals 0. Okay, not 100% sure if this is going to work or not, because look, all of these have a factor of 2. Let's factor a 2 out of everything. Divide everything by 2, and that'll give us 2x plus 5y plus 4 equals 0. That should work for sure. Okay. Also on here, normally it doesn't specify it in here, but you want to have the x term should be positive. So if for some reason at the end this was negative 2x plus 5y plus 4 equals 0, you'd want to switch all your signs so that your x was positive. Okay, let's check on our mark scheme and see how we did. Let's see, that's the other one. Let's go down to 7. Okay. First one, award M1 for correct substitution of 3, -2 into the L1 equation, which we did this, and we got that K was -9.5, so there's our points for that. Part B, we could have -2/5, which is what we came up with first, and we actually converted it into -0.4 for our next part, so we're good on that. And then we took that and they plugged it into the point slope formula, which we could have done, which would have been just fine. But then down here, it also shows plugging it into the formula that they gave us. So we did this exact thing right here. So you get 1 point for showing the slope and the given point, 3, -2, into the equation. Okay, and then we'll get another point for showing the correct equation of the line, which is what we got, y equals -0.4x minus 0.8, or you could have left it in fraction form like they have here. Either one of those is fine. And then the last part is, oh look, there's our 2x plus 5y plus 4 equals 0, right? 2x plus 5y plus 4 equals 0. So we had that, but it does say or any integer multiple. So that means that this 4x plus 10y plus 8 equals 0 would have also gotten us full credit. Okay, so either one of those would have worked. Okay, follow through from part C. So again, if you mess something else up here and you use that wrong information correctly down here, you would have still gotten your points. Okay, all right, on to number 8. Okay, number 8. The lifetime L of light bulbs made by a company follows a normal distribution. Okay, L is measured in hours. The normal distribution of the curve L is shown below. A, write down the mean lifetime of the light bulbs. Okay, so the mean is the average, right? That's going to be the part that goes right down the middle here. So what you'd probably want to do on this is actually use your ruler to draw a nice straight line. So I'm going to start here right in the middle. I'm going to use my pretend ruler, and look, that runs right down here at 5,800. Okay, so write down the mean lifetime of the bulbs, 5,800. This is 1 point, and it says write down. There's no calculation needed. Okay. The standard deviation of the lifetime of the light bulbs is 850 hours, right? So that means 850 hours this way would be one standard deviation, minus 850 from that would be one standard deviation that way. Okay, find the probability that 5,000 is less than or equal to L, which is less than or equal to 6,000 for a randomly chosen light bulb. So remember, L is the lifetime in hours of the bulb. So they're saying find the probability that a light bulb is going to last between 5,000 and 6,000 hours. Okay. Now, it doesn't specify it on here, but what you want to do on this is you want to show this range here on your graph or on a similar graph. You'd want to make, you're going to have to recreate this graph on your answer sheet. Okay, so what we want to do is we want to find where 5,000 would be. Okay, so the difference between these two is, let's see, what's that? That's 52 to 58. That's 600. So there's 300. So 5,400 would be about there. So sorry, I'm in the wrong spot over here. So let's see, this is B 49 right there. So there, right about there is going to be about 5,000. So we want to draw a nice straight line right up through there. Trying to make it as obviously straight is going to be good, and then you want to try to make it go hopefully straight up as well, so it should be a nice vertical line. And then we got to go over to 600. So there's 5,800, there's 64. That is also a difference of 600. So there's 300. We want about 200, so that's about right there. So I'm going to draw myself a nice straight line here too. And we want to find all this area in here. So let's paint this thing in here. We want to know all this area right in between these two lines of this curve. Okay. Again, the hard part about this is it does not specify in here that you have to show this graph here, but once I show you the mark scheme, you'll see that it actually, this is part of your score, is having this piece in here. Okay, so that's showing the 5,000 to 6,000. Okay, so now what we actually have to do is actually find what that probability is, which is what it says, but they also are going to give you a point for having that on there. Okay, so let's do that, and that's on our, we're going to find that on our calculator. Now, here's the key word in here that's going to hopefully help you figure out what to do on your calculator. This is a distribution. If you look on your calculator, here's your distribution. It's second, oops, got to turn it on first, second, and then variables. Up above that is distribution. And whenever you're looking for the, they're giving you a lower bound and an upper bound, that's where you always want to use the normal CDF. Right, so we do normal CDF. The lower bound is 5,000, so we do 5,000. The upper bound is 6,000, so 6,000. And then this little mu here is our mean, and the little super O, we like to call it, if you remember that, that is our standard deviation. So our mean here was 5,800. And then our standard deviation, they tell us, is 850. So we'll do 850 on that one. And then we just push enter, and it's going to paste it into our normal CDF formula here that it gives us. And we push enter again, and we get 0.4197. So the probability to the third significant digit is going to be to the 9. So that 7 tells the 9 to get bigger, so it's going to be 4.420. Okay, so we get 0.420. You're going to want to put the 0 on there just to show that you rounded it to 3 significant figures. Okay, so there's that. So that's our probability, and again, this here is going to play a part into this one as well, even though it doesn't specify anywhere in there about showing it on the graph. Let's see, last part. The company states that 90% of the light bulbs have a lifetime of at least K hours. Okay, so find the value of K, give your answer correct to the nearest 100. Okay, so now it's not going to be 3 significant digits, it's the nearest 100. Okay, so what you got to do here is, hopefully you can remember that whenever you get percents on your distribution, we're going to still go back into distribution, so we'll do second distribution. And then whenever you're talking about percents, that's always the inverse normal. Okay, so we're going to do inverse normal. And then it's going to ask you for the area. Okay, so what we want to do here is, again, we want to draw another one of these little graphs. So let's do that over here. So here's our graph, right? And again, you want to take the time to copy all the stuff down that they gave you, right? So here's our 5,800, 6,400, 7,000, 5,200, and 4,600. Okay, try to make it as accurate as you can. Mine's off a little bit, but we'll go with it for now. So now it says 90% of the light bulbs have a lifetime of at least K hours. So what most people are going to want to do is say, oh, 90%, I want to find the 90th percentile and find that. No, 90% of the light bulbs mean it's the top 90%. So what we want to do is we want to find what 10% is. Right, and then we want to find all this area up here. So we draw our graph, and then we want to find all of this area here. Okay, so we would just color all of that in. Right, something prettier hopefully than that. But again, here's 10%. We want to find this up here, this shaded area is the top 90%, and that's what they're saying, 90% of the light bulbs. So Back in here, we want to, again, find 10%. So instead of 0.9, because a lot of people want to put 0.9 in there, but you want to find the top 90%, which starts at 10% and is above. So 10%. And then again, you're going to go back to your standard, sorry, that's your standard deviation. That's your mean. Mean is 5,800. And then your standard deviation is 850, right? And we paste that in there and we push enter and we get 4,710. So that means that right there's 4,600, there's about 4,710. It's all of this and above, which would make sense, I hope. Okay, so the value of K is, so K is, I forgot it already, 4710.68. So remember, it says to the nearest 100. So 7 is the 100. So 47, the 1 tells the 7 to stay the same. So it's going to be 4,700. Okay, let's check that against our mark scheme and see how we did. Okay, so let's see. That's the old one. Let's go to number 8. Okay, so there's the first one. Write down the mean. There's our 5,800. Okay, and there's our calculation for the second part here, which was the probability that's between 5,000 and 6,000. So again, notice here on the mark scheme, it says award M1 for correct shaded area shown. And that's what I was talking about earlier. You have to show this shaded area. Okay, and then also come up with the 0.420. Okay, I have a little bit of a problem with that because, again, they didn't specify anything about showing the shaded area. But I don't think they're too concerned about my opinion on that, so we'll just go with it. Okay, so here's our 4,700, which is what we got. And then again, notice down here it says award M1 for the correct shaded area shown. So here's our, they put K there, and then here's all of our shaded piece there. Okay, correct rounding off. A1 is awarded for the correct rounding of their answer to the nearest 100, so 4,700. Okay, so really going back to our this thing here, there's our 10%. We might want to just add on, like they had there, there's our K value. And then all this up here is our what we were looking for. That's that top 90%. Okay? All right. Moving on to number 9. In this question, give all answers correct to the nearest whole number. Okay? Loic traveled from China to Brazil. At the airport, he exchanged 3,100 Chinese yuan. I'm probably mispronouncing that. I apologize. To Brazilian real. Probably mispronouncing that too. At an exchange rate of 1 CNY, the yuan, to 0.3871 real. No commission was charged. Okay, so that should make it a little bit easier because there's no commission here. Calculate the amount of BRL, the Brazilian real, that he received, or she, Loic. I'm not sure what, I've not heard that name before. So, we start with 3,100 yuan, okay, and then now we want to convert it. So we want to get rid of the yuan, so we want to put the Y on the bottom so that these yuan are going to cancel out. And so that means we're going to want to put the real on the top. Okay? Or real, whatever it's, however you pronounce that. So there's 1 yuan, so the 1 goes on the bottom, and then the 0.3871 real goes on the top. So then this would just tell us that we're going to multiply 3,100 times that 0.3871. Okay, so 3,100 times 0.3871 gives us 1,200.01. Okay, and it says right up here, round to the nearest whole number. So that's going to equal 1,200, and you definitely want to put your label on this one here. It's the real. So it's this one here. It's the Brazilian. So B RL. Okay, so that's this first part here. Okay, when he returned to China, Loic changed his, okay, there we go, it's a he, his remaining Brazilian real at a bank. The exchange rate at the bank was 1 CNY equals 0.3756. So it's a little different than that one, if you'll notice. And a commission of 5% was charged. He received 285 CNY, which is the Chinese yuan, right? So, 1, calculate the amount of Chinese yuan Loic would have received if no commission was charged. So, for that there, for B1, we got, he ended up with 285 yuan, okay, but he was charged a 5% commission. So, he's only getting 95% of what he would have had if there was no commission. So we are going to want to take what he ended up with and divide that by 0.95 to see how much he would have gotten originally. Okay, so we take 285, divide by 0.95, and we get 300. And that's 300 yuan, right? Okay, so that's what we would get for B part 1. Okay, calculate the amount of Brazilian real Loic exchanged when he returned to China. So what we're going to have to do is we're going to have to basically work backwards. Okay, so he ended up getting this many yuan. Okay, before his commission he had 300, so that's how much he ended up converting into, right? So we got B part II here. He ended up getting 300 yuan, right? So we want to use our conversion here. We want to get rid of the yuan, and we wanted to be back what we started with, which was the Brazilian real. So there's the real on the top here. So here's our exchange rate, 1 yuan, and then we got 0.3756 real, right? So then those yuans are gone and it's back into real. So let's figure that out. 300 times 0.3756, right? Yep. Okay, and we get 112.68. Nearest whole number, so 112.6 is going to be 113. So he's going to end up with 113. He started off, with 113 real, and then he ended up getting 5% taken off of that, excuse me, and then ended up with 285 yuan. Okay, so calculate the amount of Brazilian Loic exchanged when he returned to China. So that's what he started with, and that's what he ended up with. Okay, let's check that against our mark scheme. Okay, so here's our part A, 3100 times 0.3871 to get 1200. That's what we got. So 1 point for multiplying by 0.3871, and then you had to also have an integer here to be awarded for your second point to get awarded. Okay, 285 divided by 0.95 to get our 300. So you got 1 point for dividing by 0.95, and then another point for getting the correct answer of 300, and it had to be an integer, otherwise you'd lose that second point. Okay, and then the last part we did, we took our 300 and multiplied it by 0.3756, which is what we did, and got 113. Okay, so 1 point for correct substitution, multiplying by 0.3756, and then having 113, and it had to be an integer. Okay? All right, off to number 10. Okay. The manager of a travel agency surveyed 1,200 travelers. She wanted to find out whether there was a relationship between travelers' age and their preferred destination. The travelers were asked to complete the following survey, 25 or younger. Here's all this here. My preferred destination is New York, Tokyo, Melbourne, Dubai, Marrakech. Okay, not sure where that is. Okay. Ooh, a chi-squared test was carried out at the 5% significance level on the data collected. Okay. So let's see, there's 1,200 travelers. I'm going to need to move it up so we can see what's going on down there. So let's do this. We've got 1,200 travelers. Okay, and let's move that so we can see the rest of what's going on here. Write down, excuse me, the null hypothesis. Null hypothesis, hopefully you remember, is the one that they are not connected together, meaning that they're independent. Okay, so we would go with preferred destination is independent of age. Or something of that nature. Okay, so part B says find the number of degrees of freedom. Okay, so look, we've got 1, 2, 3, 4 things here. And then we've got 1, 2, 3, 4, 5 things here. So if you remember degrees of freedom, it's going to be 4 minus 1 times 5 minus 1. Because if they're going to set this thing all up, you'd have all of, like, maybe say all these across the top, and then you'd have New York, Tokyo, Melbourne, Dubai, and Marrakech all down the side. So that'd be 5 different things down the side. So you'd end up with 4 by 5. So it's 4 minus 1 times 5 minus 1, which is going to be 3 times 4, which means our degrees of freedom would be 12. Okay? The critical value of this chi-squared test is 21.026. Okay, let's see. Oh, there is more stuff down there. Use this information to write down the values of the chi-squared statistic for which the null hypothesis is rejected. So the null hypothesis is rejected when chi-squared is greater than the critical value here. So 21.026. Okay, and I really should put chi-squared calc, right, is greater. So that is our, write down the values of the chi-squared statistics for which the null hypothesis is rejected. So if the chi-squared calc is greater than 21.026, then we would reject the null hypothesis and therefore accept the alternate hypothesis. Okay? From the travelers taking part in the survey, 285 were 61 years or older and 420 preferred Tokyo. Calculate the expected number of travelers who preferred Tokyo and were 61 years or older. Okay, so to figure that out there, that's where you would, we got to multiply so we've got the 61 years or older, 285 were 61 years or older, and 420 preferred Tokyo. So what we got to do is, remember, we got to multiply those two numbers. So we're going to have to take 285 times 420 and divide it by our total number of travelers, which is up here 1,200, which was up in the original description up there. Okay, so we're going to divide that by 1,200, and that should give us our that should give us the expected number of travelers who prefer Tokyo and were 61 years or older. Okay, just really quick again where this comes from. If we had our actual table all drawn out, I don't know if I can quite fit everything in there, but we'll give it a go. Ooh, sorry. So we've got the 4 columns down this way, right? That's 25, 26 to 40, 41 through 60, and 61 or older. And then we also have the 5 different places that they all wanted to go, right? Okay. So let's say that this was the 61 or older. And then let's see, Tokyo was here. So what they're saying here is that the 285 were 61 years or older. So that means all of these here added up to 285. Remember that? And then 420 preferred Tokyo. So that means that all these here added up to 420. And then, of course, this total number down here of all the people was the 1,200. So remember, you take this number times that number, the column total times the row total of this cell right here. So that's where they cross, Tokyo and 61 years old. And then divide it by the total number. So that's where we get our 285 times 420 over 1,200. Okay, so we put that, turn that on, and we've got 285 times 420 all divided by 1,200. And we get 99.75. So that rounded to the third significant digit would be 99.8. We would expect 99.8 people, right? So the number of travelers who preferred Tokyo and were 61 years or older would be 99.8. All right, let's check that on our mark scheme here. So let's see, age and preferred destination are independent. That's pretty much what we had out here, right? Preferred destination is independent of age, so that should work out okay. It says, note, except there is no association between preferred destination and age, except not dependent, but do not accept not related or not correlated or influence. So you got to have independent in there somewhere. Okay, independent or not dependent. Okay, then they also would take no association, but it's easiest if you put independent or not dependent. Okay. Next one, degrees of freedom. There's our 4 times 1 times 4 minus 1 times 5 minus 1, which was 12, which is what we got. Okay, so we've got our points for that. Chi-squared calc is greater than 21.026 is our rejection inequality. Okay, do not accept chi-squared calc is greater than chi-squared critical value, because they actually gave you the critical value without the numerical value. So we had that, so we're good. Okay. And then here's our 285. Oh, wow. Oh, here we go. This is what we use. 285 times 420 divided by 1,200. Award M1 for correct substitution into the correct formula, which is, we did this one. And that's fine. And then also we got our other point for getting our 99.8, right? Which was rounded from 99.75. Okay. All right. So we're good on that one as well. Moving on to number 11, which we cannot see because we scrolled it down. All right. Okay. Consider the function f of x equals ax squared plus c. Okay. Find f prime of x. Okay. That's just our derivative function, right? So that means this 2 is going to come out front here, right? So we've got 2ax. And we subtract 1 from that 2, so ax to the first, or just 2ax. And then c is our constant. And so remember, the derivative of a constant is, it'll just turn into 0. So we have 2ax is our f prime of x, which is, again, remember, the derivative. Okay. And again, if you forgot about this c, that really is cx to the 0. So you multiply the 0 times c. And 0 times anything is going to give us 0. So that would be just plus 0. So we just leave it as 2ax. So there's our derivative. Point A, negative 2, 5, lies on the graph y equals f of x. The slope of the tangent to this graph at A is negative 6. Find the value of A. Okay, so what we're going to want to do for that is we have our derivative here. So we got 2ax, and it says the slope of the tangent to this graph at A is negative 6. So we know that this equals -6. Okay, and then it's at this point A, which is -2, 5, is where the slope is -6. So we also want to take this -2 is our x value. We want to plug it in for that x. So it's really 2a times -2 equals -6, right? So 2 times -2 is -4a equals -6. Divide by -4, and we get that a is 1.5. Okay, so we've now found the value of a. Okay, part C, find now the value of C. Okay, so what we're going to want to do to find the value of C, the only spot that shows up is up here in our original equation, right? So remember that f of x is the same thing as y, right? So let's start plugging in information that we have. So let's just so we have this, so we know where we're at. We got y equals ax squared plus c. So we know that this point is on this function right here. So we've got 5 for y. We just figured out that a is 1.5. X is -2 squared plus c. So now we only have one variable, so we just need to solve for that c. So we got 5 equals 1.5 times -2 times -2 is +4. So 5 equals 1.5 times 4 is 6 plus c. Subtract 6 from both sides, and we get that c equals -1. Okay, let's check that against our mark scheme and see what we've got. So part A is supposed to be 2ax. That's what we got, so we're good with that. Part B is a equals 1.5. Okay. Let's see. Let's go back to A. Award A1 for 2ax. Award nothing if other terms are seen. So if you have anything else besides 2ax, then you're in trouble. You don't get the points. Part B, we do 2a times -2 equals 6. So award a point for the correct substitution of x equals -2 into the slope function. And then another point for equating their gradient function to -6. Okay. And then the last point there is for coming up with a equals 1.5. So 2a times -2 equals 6. Let's make sure that we had that. 2a times -2 equals -6. So we got all the points there on B because that was a 3-pointer. Okay. All right. Correct substitution. There it is. There's that one. And then for equating the slope function to -6, we did that, and then we got 1.5. So there's all 3 points. All right, last one, 2 points. So we did 1.5 times -2 squared plus c equals 5. We just had 5 on the other side, but we had that exact equation. So 1 point for correct substitution of our A point, which was 1.5, right from there. And then follow through to end up getting, sorry, not follow through. In case you got something wrong, that's what follow through is always talking about, if you use your wrong answer correctly. And then we got that c equals -1. There's our second point. So we got all our points on that one. Okay. All right, moving on to number 12. In this question, give all answers correct to 2 decimal places. Diogo, I hope I'm pronouncing that right, deposited 8,000 Argentine pesos, ARS, in a bank account which pays a nominal annual interest rate of 15% compounded monthly. Okay, find out how much interest, notice they bolded it for you and everything, that Diogo has earned after 2 years. Okay, now this is where you can use the compound interest formula that they give you, which is somewhere on here. I'm not sure where it is. I probably already missed it, didn't I? There it is. Here's the compound interest formula, which let's just get familiar with this one. Unless if you have the compound interest formula that we were using in class a bunch, which was A equals P times 1 plus R over N to the N T. I'm just debating on which one of these I should use. This one is the one that we used for all of our compound interest formulas, problems. But you know what? Let's just use the one that they gave us on the formula just to make sure that you know how to use that. So I'm going to copy that down and let's try. Okay, here's that compound interest formula that is on your sheet. So FV, future value, PV is present value, N is the number of years, K is the number of compounding periods per year, and R% is the nominal annual rate of interest. The big thing I don't like about this here is the R. Okay, because this R% here, you know what? It does have the K in there. This is going to work. Never mind. I take that back. This will work okay. So he deposited 8,000 pesos. So that's the present value. So let's plug that in. So we get 8,000 is our present value. 1 plus nominal interest rate of 15%. That is a crazy high interest rate. Okay. So we got 15%. So that's our R. So we do 15 here all over 100 times K. And you remember K here is the number of compounding periods per year. So it says it's compounded monthly. So that K is going to be 12, right? So there's a 12 here and a 12 up here. And then N is the number of years. So this is, how much interest Diogo has after 2 years. Okay, so we got to put a 2 up here. Okay, so this formula here is going to work out okay. This formula is a little bit better than the one that is used in our book that I can remember. Anyway, so that will give us our future value. But remember, they're asking us for our interest. Anyway, let's figure this out first before we get too ahead of ourselves. So let's put this in. We got 8,000. I'd put it in just like it looks, except for if you'll remember, we normally multiply this out first so we don't mess that up. So 12 times 2 is 24. Okay, so we do 8,000 times 1 plus 15 divided by 100. Let's multiply this one out here first as well. So that's going to be 1,200. So we can do that. So divided by 1,200. Close our parentheses and take it to the 24th power. Okay, and that gives us that the end amount is $10,778 dollars here. Okay, so let's see. In this question, give all answers correct to 2 decimal places. So that's going to be 10778.81. That is our future value, right? Is that right? 10778.81. Yep, that's our future value. Okay, now it says how much interest he has earned. So that's how much money he has in his bank, but he originally put in 8,000. So we got to take that number, 10778.81, and subtract our original investment of $8,000, right? So take that minus 8,000, and we get that his interest is 2778.81. Oops. Equal 2778.81. 0.81 is his interest. Okay. Carmen also deposited some money in a Argentine pesos in a bank account. Her account pays a nominal annual interest rate of 17% compounded yearly. After 3 years, the total amount in Carmen's account is 10,000 Argentine pesos. Find the amount that Carmen deposited in the bank account. So now we're going to be looking for that. For part B, we're going to be looking for that present value, right? So we know that she ended up with 10,000, and we want to figure out what the value was that she originally invested. So now we have 1 plus our rate, which was 17%, all divided by 100 times the compounding periods. It's compounded yearly, so that's just times 1, right? And then there's a 1 there, and this is at 3 years. Okay, so what we want to do here is we got 10,000 equals PV, and remember this PV is just one variable. And then we can actually calculate what this number here is. So let's figure out what that is. So we've got parentheses 1 plus 17 divided by 100 times 1 is just 100. All to the third power. So ends up being 1.601613. Here's what I would do if I were you, because usually it's best to not round until you're all done with your problem. So I'm going to leave that 1.6016 times 1.601613 in there, right? And we want to end up, to figure out what PV is, we got to divide that 1.601613 by both sides. So 1.601613, and that will give us what our PV equals, our present value. Okay, so easy way to do that is just do 10,000 divide by second answer, right? And that will give us what the original value had to have been. So in this round to 2 decimal places, so 6243.71. Oops. 6243.71, and that's the ARS, right? ARS is the value that they originally, the amount that Carmen deposited in the bank originally. So that's a pretty good amount. Got a lot of interest on that. Okay, so let's check it against our mark scheme and see how we did. Okay, so the first time an answer is not given to 2 decimal places, the final A1 is not awarded. So let's see, this is the thing that we plugged into our formula, which looks like is what we had. So let's see, there's all sorts of different things. So you could do it this way, you could do it this way. Let's see, this is what we did, this one up here, right? And let's see, these are all different ways. You could have done that on the calculator. Look, there's all sorts of ors in here. Okay, here's what we're looking for. We ended up with 2,778.81, right? 2,778.81. So we are good, excuse me, on that. Okay, so we got our points for that. Final answer must be to 2 decimal places for the A1 to be awarded. Okay, so we got the first one right. Part B, again, you could have done it in this is, I think, the TMZ solver. We didn't really talk much about that because that is just not a super intuitive way to solve this. We would much rather solve it with the formulas where we can make it make sense. Okay, so we did we did this one right here, didn't we? Yep, this is the formula that we use. So we got a point for substituting into the correct formula, and we got 6,243.71, and it must be the 2 decimal places, which is what we had. And there's our 6243.71. Okay, so we are looking good for full marks on that one. Okay, we've got 3 to go. Let's take a look at 13 here. The golden ratio was considered by the ancient Greeks to be the perfect ratio between lengths of 2 adjacent sides of a rectangle. The exact value of r is 1 plus root 5 over 2. Excuse me. Write down the value of r. So really we're just going to calculate that thing out, right? So we've got 1 plus the square root of 5, and that's all in the numerator, so I'm just going to push equals. It gives me that, and then we're going to divide that by 2, and there's our golden ratio, 1.6180, so forth and so on. Write down the value of r, correct to 5 significant figures, right? So 1, 2, 3, 4, 5. Excuse me, 5. There's the 5th significant figure. The 3 tells the 0 to stay. Excuse me. So we got 1.6180. 80 is our value of r to 5 significant figures. Correct to 2 decimal places. So now there's the second decimal place, so that's going to be 1.62 to 2 decimal places, right? That's 2 points for putting something in the calculator and then rounding it. Okay. Phidias is designing rectangular windows with adjacent sides of length x meters and y meters. The area of each window is 1 square meter. Okay, so they're saying that we've got, say, x times y, and we know that those multiply together to get 1. Okay. Excuse me. Write down an equation to describe this information. Oh, okay, so there we go. We can do x times y equals 1 square meter, right? Okay, so that's this part here. Okay, Phidias designs the window so that the ratio between the longer side y and the shorter side x is the golden ratio r. So let's see, if y is the longer side and x is the shorter side, and its ratio is 1.6, that means the bigger number y has to be over the smaller number x to get our golden ratio. Because if you had the smaller number over the bigger number, it would be less than 1. Since it's more than 1, it's got to be the big over the small. Okay. I think that's all we need for that. Okay. Write down an equation in y, x, and r to describe this information. Oh, that's what we just did there. I got a little ahead of myself, sorry. Find the value of x. Okay. If we're looking to find the value of x, probably be a good idea to have things in terms of x. So let's do this. We have y over x equals r. Let's multiply both sides by x here. And we now know that y is the same thing as r times x. So up here on this y, we can get rid of the y, and now we will call it r times x, right? So that means we know that to find the area, we do multiply length times width, right? So we know now that we can do x times r times x, and that should equal 1, right? So that's really x squared r equals 1. So for solving for x, we know we'd have to divide both sides by r, right? So there's our x squared equals 1 over r, which is 1. I'm going to use the one that's a little bit more accurate here, the 1.6180, right? Excuse me. So we can calculate that. So we know that, let's do this, move this up here when we're done. So we've got 1 divided by 1.6180 gives us this 0.61. Excuse me. Gives us 0.618046. That's funny. Look, it's the same number there. So we've got x squared equals 0.6180, and then we'd want to square root that to figure out what x equals, right? So we would just square root our answer, and we get x equals 0.78615, right? So let's see, to describe this information. So we've got to round that to the third significant figure, so we get 0.786. 0.786 is what x should be. Okay, let's check and see how we did on that. Okay, so first one, 1.6180 and 1.62. 1.6180 and 1.62, so we're good on those. There's our points there. Part B, x times y equals 1, which is what, let's see, write down an equation. Oh, there we go. X times y equals 1. That's what we had. So we're good on those points too. Part C, we have y over x equals r, or we could have done this here. But we just did y over x equals r, so we're okay on that. And then part D, we have x squared times r equals 1, right? So it says award 1 point for substituting your part into part C into their equation from part B. So we substituted our y over x equals r into our x times y equals 1. It was what we were doing on there. We're okay. Okay. And then we solved it and got 0.786. So if you look back at this here, we got, there's our, where did it go? X squared r equals 1, right? And then we solved that and got that x was 0.786, which is exactly what they have here. Okay, all right, on to number 14. Okay, population of 200 rabbits was introduced excuse me, to an island. 1 week later, the number of rabbits was 210. The number of rabbits n can be modeled by the function n of t equals 200 times b to the t, where t is greater than or equal to 0. Okay, and t is going to stand for time here. Oh, there it is. T is the time in weeks since the rabbits were introduced to the island. Okay, find the value of b. Okay, so we know that originally there was 200 rabbits, right? And then 1 week later it was 210 rabbits. Okay, so let's plug that into our formula. So b of t, so with this here, 1 week later, there's our 1, and that's, we have our 200 is our starting value, and we know that we ended up at 210, right? So b to the first is just plain old b, so all we need to do is divide both sides by 200, and that will tell us what our b equals, right? So we take 210, divide it by 200, and we get that our b is 1.05. Right, and that's our growth rate, right? So that means it's growing by 5% every week. Okay, calculate the number of rabbits on the island after 10 weeks. So now that we found b, we can substitute that in to b in our equation here. So to to do this part here, part B, we're going to do the number at 10 weeks. Please remember that this is not n times 10. It's just the number at 10 weeks is going to be 200 times 1.05 to the 10th power, right? Because that's after 10 weeks. So we will put this into our calculator. 200 times 1.05 to the 10th power means that we are now up to 325.77. Obviously, you can't have a partial rabbit. And anyway, there's the third significant figure anyway, so that would be 326. So the number of rabbits at 10 weeks, 326. Okay, that's part B. Let's see. An ecologist estimates that the island has enough food to support a maximum population of 1,000 rabbits. Calculate the number of weeks it takes for the rabbit population to reach this maximum. Okay, so we still have our formula here, and now we're trying to figure out when is that population going to reach 1,000. So 1,000 equals 200 times 1.05 to what value of t. Okay, so first thing we got to do is get rid of that 200. So we divide both sides by 200, right? And that gives us 5. 1,000 divided by 200 is 5 equals 1.05 to the t. Now, a lot of people will go through and make a table on the graphing calculator. It's just going to be so much easier to just use good old logarithms. So let's let's do that, right? So simple way to do it, if you don't remember how to convert from exponential form into log form, which is easily forgettable, just take the log of both sides. So log 5 equals log 1.05 to the t. And remember, when we take the log, this exponent now comes out front. So it's log 5 equals t log 1.05, right? So we got to get t by itself, so we got to divide by log 1.05. Log 1.05. And t is the time is just going to be log 5 divided by log 1.05. Okay, so log is on here somewhere. There it is. Log 5 equals divide by log 1.05. And we get 32.986. So the number of weeks it's going to take. If we just did 32, it wouldn't quite be to 1,000, so it's going to take 32.98. Thankfully, it doesn't leave any, rounding to be had here. Either way, it's going to be 33 weeks. If you round to the nearest week, or even if you round to the nearest tenth of a week, either way, we're going to get 33 weeks. So 33.0 weeks is going to be how long it takes for that rabbit population to get to the maximum. Okay, I think that's it on there. Let's look at our mark scheme and see how we did. Okay, so first one, we did 210 equals 200 times b to the first. That's exactly what we did. And we awarded M1 for correct substitution into the equation. We got b was 1.05. Okay. The second part, we took 200 times 1.05 to the 10th power, and we got 325. Is that what we got? Ooh, we got 326. There is a problem here. Let's double check our math here, or my math. Let's be specific. 1.05 to the 10th. 325.77. Okay, I see where they're coming from with this, because I rounded to the 326, but really we'd have 325 and a little bit less than that next rabbit, so they are just basically chopping this number off here and going to 325. Let's see what it says on this thing if we got 326. It does just say the answer must be an integer. So let's change this here to 325 because it wasn't quite the next full rabbit, so they're just saying there's 325 rabbits. Okay, we can live with that. Okay. Let's see. Next part, C. There's our answer. We had 32.98, and so we rounded it to t equals 33.0. So it says award M1 for setting up the equation. We did, accept alternative methods such as this, which is, excuse me, what we ended up doing, or a sketch, which we did not need to do, and y equals 1,000, indication of point of intersection. So we didn't graph it, we just did our logarithms, which made our life easy, and then follow through. So we're good. Follow through, remember, is again if we messed up something else from earlier. This 325 didn't have any bearing on that, so we're all good. Okay, all right. That takes us to the last one, number 15. Company sells fruit juices in cylindrical cans, each of which has a volume of 340 cubic centimeters. Surface area of a can is A centimeters squared and is given by this formula here, okay, where R is the radius of the can in centimeters. To reduce the cost of the can, its surface area must be minimized. So find dA of dr, which is the derivative, right? Okay, so we got to find the derivative of this. Remember to find the derivative the nice easy way. We can't have the fractions. We got to move that r up to the top. So this is a equals 2 pi r squared plus 680 r to the, since it's r to the first on the bottom, it's going to turn into r to the negative first on the top. Okay, now we can take our derivative. 2 times, so remember this 2 comes out front here, 2 times 2 is 4, so we got 4 pi r, subtract 1 from that, that's 4 pi r to the first, so we can just leave it as 4 pi r. And then this negative 1 times 680 is negative 680. R to the negative 1 and another negative 1 is to the negative second. Okay, so there's our derivative. Might be a good idea to move that negative 2 back down. I'm not sure if they're going to nitpick on us on that or not, but let's just try it anyway. 4 pi r minus 680 over r squared is our derivative for that there, right? Okay. Part B, calculate the value of r that minimizes the surface area of a can. So minimize the surface area. So a couple ways we can do that. We can take this and set the derivative equal to 0 and solve it, or I'm going to suggest finding the minimum on our graphing calculator, right? So let's try that out. So in our graphing calculator, we're going to want to enter in our original function here, right? Without obviously the a in there. So I have taken the liberty to enter that in already. So we got 2 pi, and here's our xt theta n. So it's officially going to show up as 2 pi x squared plus 680 divided by x. Okay, now hard part on this here is going to be figuring out what to set our window to. Okay, so the r is the radius. Obviously it doesn't make any sense for the radius to be negative, so we're going to set the minimum to 0. Maximum radius, if we've got a volume of 340 centimeters, I'm just going to throw out, like, I don't know, let's see, 200 would be probably too big. Let's just go with, say, 100 for now and see if that works. Scale of 1, we don't really, are not too concerned about that. Y minimum is the volume, right? let's see, oh, no, wait, the surface area. So we're minimizing the surface area. So obviously you cannot have a negative surface area, so the y minimum is going to be 0. And then now the maximum, so like we're talking about the surface area of the can. We don't know what the surface area of the can is going to be. The volume is 340 cubic centimeters, so let's maybe put in, I don't know, maybe 1,000 and just see what happens. So we graph that, and look, there we found what our minimum is. If you want, you can do a zoom box and try to zoom in on that to get a little bit better idea. Or you could even just say, okay, obviously our x value is way too big, so I'm just going to change my max x value to maybe, looks like 20 is going to be more than enough. So there, that's going to be a little bit easier to find that. So now all we got to do is just find that minimum value, right? Second, calculate, find the minimum, get it to the left bound, get it to the left of the minimum, enter, and then move it over to the right of the minimum, enter, enter, and there's our minimum, 3.7823. So if we round it to 3 significant figures, 3.78. So the R equals 3.78, and this is all in centimeters. Okay, not that they asked, but the surface area would then be 269 or 270 square centimeters, but they didn't ask that, so they just asked for this. Okay, now it says at the very beginning, if you're using your graphing calculator to figure stuff out, show a graph. So here's what we're going to want to do. We're going to want to sketch this graph on here. So in your spot where you have all your work, you're going to want to sketch your graph, and you're going to, whenever you have a graph, you always want to label it. Okay, so we're just going to do this here. So that's kind of what our graph looks like. And then here's what you want to do. You just want to label that minimum point. So 3.78 and, oops, 270. 270. There's our minimum point there. Okay. This here is going to be our radius. I think we're probably going to be all okay without it, but radius of the can, right, in centimeters. And then this here is going to be our volume. Oh no, sorry, not volume, because this, we're talking about the surface area of the can, right? So surface area in, so we do, this is going to be in square centimeters, right? So that sketch there, I believe, would get us credit on that. Let's check our mark scheme. Okay, so first one, we've got the derivative 4 pi r minus 680 over r squared. Okay, and it says award A1 for 4 pi r, or you could have written 12.6 radius times the radius, sorry. And you get another point for the negative 680, and then another point for the 1 over r squared, or r to the negative second. So up here where we had r to the negative second, they would have taken this answer or this answer. Okay, so either one would have been fine. So there's 3 points right there. Part B says 4 pi r minus 680 over r squared equals 0, and then you'd have to go through and solve that all. Okay, and then if you look far enough down here, it says, or a sketch of A with some indication of minimum point. Okay, so award M1 for sketch of A and M1 for indication of minimum point. Okay, which we did. That is this right here. Here's our sketch. Here's our minimum point. And we put a little, you definitely want to put a little dot there to show that that's the minimum point, right? So there's 2 points for that right there. And then we just got to see if we got the right answer. And there it is, 3.78 centimeters. Tell me that we put centimeters on there. Yes, 3.78 centimeters. So there's our third point for that also. Okay. All right. That's it. That's all of paper 1. Okay. If you have any questions on any part of any of this, please be sure to ask in class. All right. Thanks.